So in the previous video, we graphed exponential functions. Now we're just going to learn how to recognize whether or not what we're dealing with is exponential. And if it is it growth or decay? All right, so to determine if a table of values represents an exponential function, we need to check for a common ratio. So remember, with an exponential function, the a value represents our initial value, which is our y-intercept. And the b value, this here is going to be that factor, which is also the common ratio. Okay, so in these tables below, we need to determine if it represents exponential growth, exponential decay, or neither. And if it is exponential, let's write the function. So let's see what's going on here. So our x's are going up by 1. That's standard. All right, but what's happening to our y's here, our outputs? Okay, it might be a little bit easier to see, not with the fractions, but like from 2 to 6. What are we doing? We're multiplying by 3. From 6 to 18, we're multiplying by 3. 18 to 54, we're multiplying by 3. What about 2/3 times 3? If I multiply 2/3 by 3, I get 2. So you see this common ratio as we're going from column to column. Our y's are being multiplied by 3, all right, which is good. That's what we want. We want that common ratio, okay? Another way we can check that, instead of trying to kind of guess and check, just take 54 divided by 18. That's 3. 18 divided by 6. That's 3. 6 divided by 2. That's 3. 2 divided by 2/3. That's 3. So our common ratio is 3. So b equals 3. Since 3 is greater than 1, this is exponential growth. All right, so if we want to write the function, we not only need that common ratio, we also need the initial value. All right, remember, the initial value is what happens if you plug in 0 for x. So this right here is the initial value. All right, so the b value is 3, the a value is 2. So our function here is y equals 2 times 3 to the x. That is our exponential function there. Let's go to the next one. In part B, our x's are going up by 1. What's going on with our y values, though? All right, our y values, this is subtracting 5, subtracting 5, subtracting 5, subtracting 5. So we're subtracting 5 there. This is no common ratio. Adding or subtracting is not exponential. So the fact that we're subtracting 5 each time, that's not exponential. All right, that's neither. That would be a linear function. So if this is a linear function, and this is kind of review, we start at 10 and we subtract 5 each time. So if we got y equals mx plus b, our starting value is 10, and our slope, what we're doing each time, is -5. All right, so this would be that function. Again, you don't necessarily, this is just review on how to write a linear function based off a table. For the purposes of our exponential unit, you just need to recognize that this is not exponential because there is no common ratio. Like if I take 0 divided by 5, that's 0. 5 divided by 10, that's 1/2. 10 divided by 15 is 2/3. There's no common ratio there. Therefore, this is not exponential. All right, you need to be multiplying by some number greater than 1 or some number in between 0 and 1 to be exponential. All right, so that is everything for 7.2. graphing exponential and also recognizing them based off a table and writing the exponential function. All right, so if you have any questions, please let me know. Other than that, make sure you do the practice problems, and I'll see you when I see you.